Back to our code, what I'll do now is I'll add that something that we were looking for. Angle mode block and put it in our condition. So instead of a touch sensor that returns a value of true when pressed, false when not pressed, we will use a gyro that can give a value that is the turn angle of the robot. Our program is almost complete. Let's just open the HUD and look at the gyro values as the robot turns to the right. I'll turn on the manual control. Let's stop the program first. Turn on the manual control, and as I turn to the right, look at this value of the gyro. We can see the values are decreasing as I turn to the right. If I turn to the left, we can see the values increase. This is an internal issue of the gyro sensor. We will need to play along and change or determine the compared value accordingly. So, help me out. What do you think our condition should be like? While the gyro get angle is higher, bigger than -90. We want the robot to turn until it reaches this value of -90. So how should our condition look like? Should we use while it equals, maybe lower or equal? Write the answer in the chat box. I see some mixed answers, and that is fine. I'll show you a nice trick how to resolve that kind of a question. Our robot, when it gets to that part of the program, has a gyroscope angle value of 0. 0 is higher than -90, and we want it, while at this position, to start its turn to the right. So since 0 is higher than -90, we will set it to higher and add the value -90 to our condition. We can test it out even without running the simulation. Let's look at the current situation of the robot where the gyro sensor gives a value of -17. While -70 is higher than 90, is this condition met? Is -17 higher than -90? The answer is yes, so the robot will turn to the right. What would happen as we move closer to our goal of -90 degrees? -77 degrees is still higher than -90. And as long as the values are higher than -90, it will continue its rotation. When it gets to -90, well, -90 is not higher than -90, it equals. So at this point in time, the loop will stop instructing the robot to turn, and we'll move on to the next block to stop the robot. Let's give it a try, but before that, let's apply the common practice I discussed earlier. Let's turn at a slower speed. Are we ready? I think we are. Let's try the code. You can watch the values from the gyro and the touch sensor as they change throughout the session. Excellent. We were able to complete a 91-degree turn. The physics engine of the simulation relies on real physics. There is a momentum to the robot, and that is why we use low speed as 20. At higher speed, there will be more momentum, and the robot will overshoot even more. Now, all we need to do is add the final touch. Drive forward for the robot to reach its objective. We already know how to drive forward. We just duplicate that block and add a positive value to make it go forward. Excellent. That's great. Now, it may feel like we've made little progress, that we just turned our robot at 90 degrees. But actually, what we have covered is much more than just turning. Let me show you what I mean. Let me show you how we can use the same concept as we just used to solve new problems using new sensors.